Okay, so I will give maybe 2 more minutes, okay? At 3:44, we will look at part C. And after we finish this, we will continue with chapter 15, okay? Yesterday, we looked at 15.1, so we will continue with 15.2. All right, so it's 3:44, so I'll erase a bit and I will explain part C, okay? So as for part C, let's see what the question asks. So calculate the volume of carbon dioxide produced at room temperature when 35 grams of calcium carbonate reacts with excess hydrochloric acid. So initially we have 5 grams of calcium carbonate reacting with hydrochloric acid, okay? With 5 grams, the mole of calcium carbonate was 0.05, okay? There was 0.05 before. Now, the mass of calcium carbonate it increases from 5 grams to 35 grams, which is 7 times the original mass. And therefore, the mole is also going to be 7 times. It's going to be 0.05 times 7, which is 0.35, I think. Let me double check. 0.05 times 7, which is 0.35. Okay, so let me repeat. At first, when the mass of calcium carbonate was 5 grams, the mole was 0.05. Now, the mass of calcium carbonate is 35 grams, which is 7 times. So the mole of calcium carbonate is also going to be 7 times. So 0.05 times 7 is 0.35. All right. So if the mole of calcium carbonate is 0.35, then the mole of HCl is going to be 0.35 times 2, which is 0.70. Because remember, the mole ratio doesn't change, okay? It is always 1:2. Now that the mole of calcium carbonate is 0.35, the mole of HCl is going to be twice, and therefore it is 0.70. Now that we know the mole of, oh wait, we don't even need the mole of HCl. We were looking at carbon dioxide. My bad. So the solution. Let me just remove this again. So we are comparing the mole of CaCO3 and carbon dioxide, okay? Not HCl. I misread the question. So CaCO3, carbon dioxide mole ratio, it's 1:1. CaCO3 is to CO2 is 1:1. So if you have 0.35 moles of calcium carbonate, then you will also have 0.35 moles of carbon dioxide. If you want to find the volume is going to be number of moles times 24 decimeter cube. It's for gas, okay? So the mole here is 0.35, and then the volume 24 decimeter cube, you multiply them together, and your final answer should be 8.4 decimeter cube. So you need to remember that any one mole of a gas will occupy 24 decimeter cube. So mole volume will change. You just have to multiply with 24 decimeter cube. Okay? So this is an important formula to remember. And the final answer is going to be 8.4 decimeter cube. So please make a note of it, and if you're done, let me know. Okay, so Mintuta and Henry. Okay, 2 people are done. One, two, three, four, five, six, seven, eight. Okay, 7. Everyone's done. All right, great. So that was yesterday's question. So today we will continue with our classwork, okay? So let me give you guys a quick recap. 15.1 daw nga, we looked at the composition of the different gases that makes up air, okay? So air is mainly made of nitrogen, about 78%. It is made of 21% oxygen, and the remaining 1% is made up of carbon dioxide, water vapor, and also noble gases. All right, and then we looked at the uses of oxygen. Oxygen is very useful because it is a raw material for respiration, and respiration is needed by our cells for energy. Without oxygen, we cannot respire. If we cannot respire, we cannot release energy, and therefore our cells cannot carry out chemical reactions that are essential to keep us alive. And after that, we looked at an experiment to calculate, the percentage of oxygen in air. So that experiment involved 2 gas syringes and copper. We burn copper using the oxygen in the air. We measure the initial volume of air, and then we measure the final volume of air. And the difference between the 2 volumes is the amount of oxygen in the air, which got used up when the oxygen reacted with carbon to form, with copper to form copper to oxide. Okay, so for today's topic, we're looking at 15.2, making use of air. So, guys, for the ones who have answered the test, the chemistry test, like the day special test, Yin here, Eric's not here, so Yin and I have checked your answer. I'll send it after class, sometime after class, okay? I keep forgetting to do that. So any test, I saw one question about the separation of air, and for that gap, the separation method that you will use is fractional distillation, which you're going to learn now, okay? So If you want to separate the gases from the air, if you want to separate nitrogen, oxygen, helium, water vapor from air, then you're going to use a separation method, which is known as fractional distillation, which was mentioned way earlier, in I think it's in chapter 2 or 3. All right. So to separate gases from air, we use a method known as fractional distillation. Fractional distillation distillation. All right. So we are going to look at how the different gases in liquid air is separated. Okay, so fractional distillation of liquid air. So firstly, I will draw the setup of liquid air. So there is this pump. Yes.
What's liquid air?
Liquid air is basically the air that has been like really condensed, so that instead of becoming vapor, it is actually in liquid form. So you cool down air so that it condenses to liquid.
Okay.
Okay, so let's look at this. Firstly, you have a pump. Okay, so the pump, you're going to let air enter inside, and then you're going to have this chamber. And in this chamber, wait, I'll explain the steps later. I'll just draw it first. So here you have right here. don't have enough space here. Right. All right, so this is the setup for fractional distillation of liquid air. So for the first step, what you're going to do is you're going to pump air into the plant. Okay, so this is the plant that carries out fractional distillation. So for step one, you're going to pump air into the plant. And there is this filter right here, and the job of the filter is to remove the dust particles from air. Okay, so air is pumped into the plant and it goes through this filter, which traps and removes dust particles. All right, so dust particles are removed. The next step, when air reaches into this chamber, what happens is carbon dioxide, water vapor, and other pollutants are removed. Okay, so in this chamber, once again, we're going to remove parts of the air, which are carbon dioxide, water vapor, and also some remaining pollutants. So the lumio remove local, but firstly, you have to cool the air. You have to cool the air until the water vapor condenses into water. After you cool the air and the water vapor condenses into water, then this water is going to pass through these absorbent beads. Okay, so there are little beads in this chamber, and the liquid air, as it passes through these beads, carbon dioxide gets trapped, and also any pollutants. Okay, any pollutants and carbon dioxide, it gets trapped in these beads. All right, so carbon dioxide is removed, pollutants are removed. Now the next step is to force the air into this little small space. So air is compressed, meaning that it is, squeezed into this little small space. And as you squeeze air inside, there is also this there is also this cooling system in the chamber, meaning that the compressed air is being cooled down, and as it cools down, it enters here. Okay, the cool air enters here, and the next step is for the cool air to pass into this larger space. My drawing mark, the space that is not very large, but actually this space is supposed to be way larger. Okay, so the cool air is then passed into this larger space, and larger space ထဲမှာရောက်တဲ့အခါကျရင်ထပ်ပြီးတော့ပိုအေးအောင်လုပ်တယ် Okay, the air ကိုပိုပြီးတော့အေးအောင်လုပ်တယ် air ကိုပိုပြီးအေးအောင်လုပ်ပြီးတော့ the air ကို the jet in this chamber, it forces the air in this passageway. Okay, and every time air passes into this loop, it gets colder and colder and colder because cool air is being blown here. Cool air is blown here, so the air, it gets cooler and cooler and cooler, and then what happens is by the time it reaches minus 200 degrees Celsius, okay, by the time it reaches minus 200 degrees Celsius, most of the air has become liquid. The only gases that are not liquid are neon and helium. Remember, air ထဲမှာ about less than 1% of air got it's made up of made up of noble gases. Some noble gases, yeah, they still are gas at around minus 200 degrees Celsius, but most of the gases they have become liquid. Okay, so here after cycling in this passageway for several times, most of the air has become completely liquid, and after that, the liquid air it passes into the next unit. Okay, it passes into the next unit, and right here, what happens is the liquid air is then warmed. Okay, we're going to heat the liquid air, and as we heat the liquid air, the gases will boil off one by one depending on the boiling point. Okay, so the ones with the lowest boiling point, they will vaporize first and they leave from this part. The gas with the second lowest boiling point will leave from this tube. The one with a slightly higher boiling point will leave from this tube, and the one with the highest boiling point will leave here. So depending on the boiling point of the different gases, they will all leave from different tubes. All right. So as for nitrogen, let's see. Here you have nitrogen. Here you have argon. Here you have oxygen. Wait a minute, I don't have enough space. Here you have oxygen. Here you have krypton. And then here you have, okay, so the temperature here got minus 108 degree. And then the temperature here got minus 153 degree. Temperature here got minus 183 degree. Oh, I should have written it here. Dima got minus 108 degree. Dima minus 153 degree. Minus 183 degree, minus 186 degree, minus 196 degree. So the elements of the gases boil off one after another, and the one with the lowest boiling point, it will escape off first. Okay, so the lowest boiling point, that nitrogen, it escapes off first, and then argon, and then oxygen, and then krypton, and then xenon. So it's a bit so I'll go over this one more time, okay? And then I'll write down the steps. So air is made up of many different gases. It contains oxygen, it contains nitrogen, it contains noble gases, it contains water vapor, it contains pollutants, etc. So if we want to separate the different parts of the air, we have to carry out fractional distillation. So the first step is to pump air into the plant, and it will first go through this filter, and the filter will trap the pollutants. Okay, so all the waste pollutants, most of the dust particles are being removed. And the next step is for the air to go through this second chamber. And the air is cooled down, and air will cool like the air it condenses into liquid. Some of the air condenses into liquid, and then the rest it passes through these beads. As it passes through the beads, the carbon dioxide is being removed, because the beads here role it is to trap the carbon dioxide and also to trap the pollutants. So the carbon dioxide, the pollutants are removed to the air, and now what remains in the air it goes down into another tube. This time the air is being compressed and the air is cooled down. And this cooling process repeats on and on and on until it reaches about negative 200 degrees Celsius. When it reaches negative 200 degrees Celsius, most of the air has cooled down to become liquid. And now that the air is in liquid form, we want to separate the different gases that makes up the air. So we're going to heat the liquid air up. As we heat the liquid air up, the gas with the lowest boiling point will be the first one to leave this plant. The the one with the second lowest boiling point will be the second lowest boiling point will be the second to leave the gas, and so on. And therefore, we are able to separate nitrogen, argon, oxygen, krypton, and xenon, all right, into different. So it's pretty messy. So what I will do is I will send a picture of the diagram and you guys could copy from there. I'll write down the notes after you have copied the diagram, okay? If you don't want to copy the diagram, that's fine as well, okay? You can just look at it anytime from Google. So yeah, this is the diagram. If you guys are done, please write down and then I'll write down the steps that I mentioned earlier, okay? Okay, so you guys are done. All right, so I'll quickly go get some water. I'll be back. Okay, so I'll write down the steps now. First, All right, guys. Please copy these steps down, and for the final step, I will write it once you have all copied this. Okay, so Henry, Meduta, MKK, and Dinnerda. I'll erase the first step and I'll write down the final step here. Okay. Sorry, as for the final step. Liquid water is pumped into the fractionating column. Okay, so the final component is the fractionating column, and it is the site where the actual fractional distillation will take place. So it's pumped into the fractionating column. COLUNN. Oh, not the liquid water, the liquid air. And is slowly warmed up. Gases boil off one by one and are collected separately. RATELY. So the first gas to boil off is the gas with the lowest boiling point, and it is nitrogen. Okay, so gases with lower boiling point will be collected, collected first. So yeah, guys, copy this final step, and that will be it for the fractional distillation of liquid air. The next thing is about uses of oxygen, nitrogen, and noble gases, and then we're done with 15.2. So I will start the next part at maybe 4:30, okay? If you guys finish copying step 5, you can take a short break if you want. I'll begin again at 4:30. Alright guys, so it's 4:30. We shall move to the next part. So now that we know how to separate the different gases from air, we will look at the uses of each gas. Okay, not all the gases, just oxygen, nitrogen, and noble gases. So for oxygen, the first use is in respiration, which we already know. So I'll just write down the other uses, okay? So oxygen is used in hospitals for patients with breathing problems, okay? So when patients in hospitals do not get enough oxygen, then oxygen is supplied through oxygen mask or oxygen tent. Used oxygen mask. Hospitals for patients with breathing problems. And as for the next use, oxygen is used to convert impure iron from the blast furnace into steel. Okay, so oxygen is used to convert impure iron to steel. And I guess that's pretty much it. So now let's look at for nitrogen. Liquid nitrogen is very cold, and so we use nitrogen to freeze food in food factories. And because nitrogen is unreactive, we actually flush nitrogen through food packaging to remove oxygen and to keep the food fresh, okay? Because oxygen promotes decaying. So if you have, let's say, a food can and you don't want the food inside the can to decay, then not you, but I mean factories. In factories, that produce food cans, they don't want the food to get decayed quickly. So the oxygen is sucked out and then nitrogen is replaced instead. So when the food can has nitrogen in it, it slows down the rate of decay because nitrogen is unreactive. Okay, so it is flushed through food packaging to remove oxygen and keep food fresh. And now we will look at some uses of noble gases. I think I've already mentioned this in the previous chapter when we were looking at noble gases in detail, but then the textbook got included so I'll just write them down again. Noble gases are unreactive, or you can say that they're inert. And this unreactive property of noble gases makes them very useful to carry out certain functions. So neon is used in advertising signs and it glows in red when the current passes through it. As for helium, it is used to fill balloons, and that is because it is very light and at the same time it's not reactive. Okay, and then we have argon, which provides ROVIDs provides an inert atmosphere in tungsten light bulbs. So let's say you have a light bulb with a light bar. I don't really know how to draw a light bulb. So inside of the light bulb must be argon shear, and that is to provide an inert atmosphere. okay? So that the tungsten it doesn't get reacted easily and it doesn't get destroyed. So the space we fill in with argon to protect the tungsten wires. All right. So copy what you think is necessary, and if you're done, let me know. I will send the questions in the group. Okay. All right, Henry, so you can start working on the questions now. 4 and 5 for Yime, please write 1 and 2, okay? 1 Yime, 2 Yime, and the third question that I'll write it down here, okay? The first question is about nitrogen, the second one is about the uses of noble gases, and the third one is why is argon obtained before oxygen in the fractionating column. So these are the 3 questions that I want you to answer. The first 2 questions that I sent them on Messenger, and this is the third question. Okay.
Okay.
Yes.
In question 3, what do you mean by obtained before oxygen?
Wait, can you repeat your question?
What do you mean by obtained before oxygen in question 3?
Oh, so if you look at the fractionating column, okay, firstly, nitrogen is removed, and then argon, and then oxygen.
Ah, okay.
Yeah.
So, okay, got it.
Okay. All right. So I have received some answers. So let me check them. So for number one, what's the question again? Okay, so Mintuta, your answer is correct for number one. Number two is also correct. Okay, so continue with three. And as for Yin, you see first. All right, Yin, your answer is correct. 1, 2, 3. Yes, all your answers are correct. Okay, so now I'll check Henry's answers. Hi. Oh, wait. Henry, nitrogen has very, very low boiling point. Okay. And then as for argon, it is removed first because it has a lower boiling point. So remember that the gas with lower boiling point will be obtained first. Okay, so if you look at all the different gases in the fractionating column, nitrogen has the lowest boiling point. So when you heat liquid air, it will be nitrogen that vaporizes first, and we will be able to collect nitrogen first, followed by argon, followed by oxygen. Okay, so it goes in the order of lowest boiling point to highest boiling point. And then Megan, actually for Dua, you have to explain the uses, okay? It's just these things, right? You don't have to write them. And yes, the last one is also correct, okay? And then, okay. All right, great. So most of you guys are done. In that case, we have about 15 minutes left. So let me see if there's maybe one short assignment that I can give you guys. Let's see. So I'll give you maybe just two multiple choice questions. Okay, that will be it. So give me one moment. I'll quickly look for the multiple choice. All right, guys. So I have sent you the picture, and anytime I want you guys to do question 4, 5, and 6. Okay, try 4, 5, and 6. After that, that's it for today. 4, 5, 6. All right, so yeah, you might want to check 4 again. And as for 5, yo, I think you have to check 4 and 5 again. Okay, 4 and 5 again. 6 is correct. So guys, remember, no, high volatility suaga low boiling point gobiora. Okay, high volatility solutions substances boil easily. They have a low boiling point. And as for Minkanga, yes, 4 a minute, being 5, check 5 again, and 6 is correct. Okay. Okay, so I have a feeling that most of you guys might be confused with A. Okay, for then your answer for A is wrong, But for not A, I mean for what am I even saying? 4 is wrong, but 5 and 6 are correct. So the guy, I'll just explain this, okay? So guys, for substances, for two substances to be the same element, they need to have the same proton number, okay? So remember that the proton number, it determines the element. So if two substances have the same proton number, so let's say substance A has proton number 19 and substance B also has proton number 19, it means that they two are the same element, okay? So substances with the same proton numbers are basically the same elements. That's the first thing that you have to keep in mind of. The second thing that ionic compounds 有gì咩事咩? Ionic compounds properties can number 1, they're soluble in water. Soluble in water. Number 2, they conduct electricity when molten. Conduct electricity when molten, and that is because the ions are free to move. Okay, the ions, yeah, molten state could be solution ions, yeah, they can move around, they can carry electric charge. And the third property, yeah, they have low volatility. Volatility is the ability to vaporize. So ionic compounds, they have low volatility, meaning that their boiling point is high, meaning that they don't easily become gas, okay? It takes a lot of energy. It takes a lot of heat energy to become gas. As for molecular substances like nitrogen and oxygen, they are already gas at room temperature, meaning that they have high volatility. They don't need a lot of energy to become gas, okay? So volatility and boiling point, yeah, they have an inverse relationship. Low volatility, so high boiling point. High volatility, so low boiling point. Okay. And the last one, got covalent bonds. Covalent bonds, yeah, they share electrons, and it's the sharing of electron between non-metal and non-metal. And covalent compounds, yeah, they do not conduct electricity. Okay, the reason why they don't conduct electricity is because covalent compounds, they are made up of molecules which are not charged particles. And second of all, covalent compounds, they don't have free electrons. They have electrons, but the electrons are used up in bonding. So they don't have any spare electron that is, freely moving around to carry electric charge. All right, so that's it, I guess. So it's almost 5-0. If you don't have any questions, you guys are all dismissed. Okay, if you have questions, feel free to stay behind, but if not, you guys can get going now. Okay, bye-bye. Yes, bye-bye.